Hi, ladies and gentlemen. I'm Teacher Nando. So today in physics, we'll be looking at electricity, and this is the first part of electricity. So we are going to define what electricity is. So the definition here says, electricity is a property of matter that results from the presence or movement of electrical charge. Now, there are two types of electricity. We have static electricity and current electricity. So static electricity, this is the type of electricity that is generated when two substances are rubbed to each other or against each other. Then we have current electricity. Current electricity, this is the movement of electrons. Okay, so these are the types of electricity. Now there is a law of electricity. Okay, so the first law of electricity states that like charges repel and unlike charges attract. Okay, so this is the introduction. So we are moving. So we have got this outline. We'll be looking at the current, charge, voltage or potential difference, and resistance. So we're going to start with current. So what is current? Current is the flow of charge in a circuit. Okay, it is measured in ampere. Okay, and the instrument used to measure current is called an ammeter. So this is the ammeter here. This is the ammeter used to measure the flow of charge in a circuit or current. Okay, so this is the just a simple circuit. So the flow of current start from a positive charge or from a positive terminal of a battery towards a negative terminal, and we have said current electricity is the movement of electrons. Right? So here electrons are moving from a positive of a battery to a negative. Okay, we are moving. So let's move on. So now here is a simple question we can solve to we just solve this simple question. So this question reads, the battery has 20 volts, resistance is 3 ohms, find the current in a circuit. Now the formula for current is I, which is current, is equal to V over R, which is voltage over resistance. Okay? What is our voltage? So our voltage here we have 3. What is our resistance? Our resistance is our voltage is 20 and our resistance is 3. So now we are going to divide 3 into 20. It will give us 6.67 ohms or ampere. So we have found our current. So we are moving to electrical charge. So electrical charge can be defined as a fundamental physical property that causes objects to feel an attractive or repulsive force towards one another. So the fundamental unit of charge is the coulomb. Okay, so charge can be abbreviated as with a capital R, and charge is measured in coulombs. Okay, which can be abbreviated as C, capital C. So there are two types of charges. We have positive charge, okay, exhibited by protons, and negative charge exhibited by electrons. Okay, if you remember very well, in my preamble I said current electricity is the movement of electrons, okay, and protons. Okay, so we are moving. So we have this simple question as well, so that we can solve. We know how questions comes. So we have this question says, in a circuit the flow of charge is 12 ampere in 6 seconds. Calculate the charge of the circuit. So the solution here is charge. The formula for charge is Q, which is charge is equal to I, which is current times time. What is our current? 12. What is our time? 6. 6 times 12, it will give us 72 coulombs. So we have solved. Let's move on. So we'll be moving to potential difference or voltage. What is potential difference? So this is the difference in the amount of energy that charge carries have between 2 points in a circuit. Okay, so a potential difference of 1 volt is equal to joule of energy being used by 1 coulomb of charge when it flows between 2 points in a circuit. So voltmeter is the instrument used to measure current or potential difference of voltage. So the units for potential difference of voltage are volts, abbreviated by capital V. Okay, we are moving. So let's move. We have this simple question. So this question needs the current flowing through a circuit is 20 or 12 ampere with a resistance of 12 ohms. Calculate the potential difference. So the formula is V, which is for potential difference of voltage, is equal to I, which is current, times R, which is resistance. What is our current? Our current is 12. What is our resistance? Our resistance is 2 by 12. It will give us 24. So we have found our voltage. Let's move on. So we are moving to resistance, which is our last part of this episode, okay, which is part 1. So resistance defined as is a measure of the opposition to current flow in an electrical circuit. So resistance is measured in ohms, okay, symbolized by the Greek letter omega, okay. So this is the symbol for ohms, which are units for resistance, okay. So we are moving. So ohms resistance can be measured by using an instrument called ohmmeter, okay. Ohmmeter is the instrument used to measure resistance. So this is the instrument used to measure resistance. So let's move. So ohms, there are laws, okay, of resistance. So the law for resistance, or Ohm's law, states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points, okay. So the current flowing through these 2 points is direct proportion across the 2 points, okay. So this is the a diagram explaining what the Ohm's law states. So we are moving. So the ohms or the resistance or the resisted, which are instrument that we use as resistance, can be arranged in a series or in a parallel way. Now in a series, okay, this is a series arrangement of ohm or resistance, okay. And for us to calculate the total resistance of a certain in a circuit, you can use this formula. So this is the formula you can use to find the total resistance, okay. We are moving. So you can find the total resistance in a parallel. This is in a parallel. So for you to find the total resistance in a parallel in a certain circuit, you can use this formula or this one here. So let's move. So thank you very much. Make sure that you subscribe to my YouTube channel, as well as you like and share.